Hello, my name is Robert Kerdman, and this is my Physics 2211 Lab 1 constant velocity. First, the agenda, I'll be covering the introduction, the principle of this lab, Newton's second law, the procedures, comparison, possible errors, and finally a conclusionary slide. So, to begin, the purpose of this lab is to compare an object's recorded experimental position in a video versus its predicted position based off a computational model using the same conditions. The objective of this lab was to record a video of an object rolling with constant velocity in a single axial direction. The video is then put into the tracker program, which plots points and allowed me to track its position and velocity. Using the data from tracker, I created a glow script code to plot the predicted position of the ball. So now to discuss the prime principle in this experiment, which is Newton's second law. Newton's second law, also known as the momentum principle, is the base principle used in this lab. How is it written? Newton's law states that the net forces equals momentum over time. We can manipulate that formula below to create the position update, the velocity update formula, which will also give us the position update formula. Now, procedures. First, I aligned the marker with the camera and put a ruler in the background as a reference. After recording the video of the marker rolling down the frame, we used tracker to plot different points per frame, which created a position versus time graph. I then took those initial conditions, which we calculated using tracker, to create a computational model in GlowScript to find the predicted values. Then we compared the predicted values to the recorded values and analyzed what occurred. In tracker, we put the video into the program and picked a starting and ending frame. And per frame, we clicked the middle of the marker where the center of mass is to plot a point. The total time of the marker rolling was 0.671 seconds, the initial position was 0, 0, 0, and the initial velocity was calculated using the change in position using the graph and the change in time, which is 1 over 30 because the camera records at 30 frames per second. So that initial velocity was 0.48100. For the GlowScript code, we were given a starter code where we edited a few lines. We changed the mass of the ball to the mass of an expo marker, 15 grams. We put in the initial position and initial velocity shown in the last slide. And we have a change in time, which is 1 over 30, again shown in the last slide. We have this while loop, which runs the code to calculate the new position and plot the points. And we have to make sure that time is no more than 0.671 seconds, because that's the total time of video that we have. Now for the comparison. On the left is the recorded values of position, and the right was predicted values. As we could see, the predicted values ended around 0.34 meters. The recorded value ends at around 31.9 centimeters, or 0.319 meters. With an r-squared value of 0.996, our recorded values were very close to the predicted result, assuming constant velocity. This occurred in a way where the recorded results were less than the predicted results, but still pretty close. Now, for the errors of why they're not exactly the same. We believe that there could have been some human error. It's possible that the marker didn't move exactly horizontal, causing a mistake in values for predicted versus recorded. It's possible that it wasn't exactly in the X direction and could have possibly been a little bit diagonal. Outside forces. While we were asked to assume constant velocity, that is not realistic. Friction and air resistance play a part in slowing down the marker, making it go less distance than the predicted values. The marker has friction with the table, and there's air resistance, meaning that the position that has an acceleration in the negative x direction, and that means that the position will be less than the predicted result. This lab was very beneficial in understanding constant velocity and forces in the real world. Due to these forces, the comparison shows that the recorded values were slightly less than the predicted values, but still very close overall. Next time, we will make sure that the marker goes in an exact straight line, and hopefully we'll have a higher FPS camera to get more exact results. Thank you very much.